Welcome to Stats with Chaz. I'm Dr. Charlie Collins. Today I will discuss the normal curve. The normal curve is the basis for most statistics and underlies probability theory, which is what statistics in the social sciences is based on. Probability theory deals with the occurrence of events and the chance or probability of those events happening. In essence, probability theory asks, what is the chance that a particular event will occur at random or given random chance? The normal curve helps us understand this. It lets us know the chance of an event occurring out of a total number of possible events. If this sounds a bit abstract, don't worry, it is. We'll get into specifics in a minute. Today, we'll cover the normal curve in more detail, z-scores, and probability or percentiles. Let's first talk about the normal curve, also known as the bell curve. The normal curve is a theoretical model line graph that has a peak in the middle and smooths down on the low and high ends. So we kind of see it like this. Theoretically, the mean, median, and mode should be the same in a normally distributed set of scores. The most important point about the normal distribution is that we can identify the exact proportion of scores above, below, or between certain points in the distribution using mean and standard deviation. For example, if I'm interested in the height among a group of students, where their group mean is 5'6" and their standard deviation is 2 inches, I can find exactly what percent of the group is taller than 6'1", 5'2", or shorter than, let's say, 5'5". When you've heard things like graded on a curve or percentile score like on the SATs, these are on the normal curve. That's what's being referred to. Meet me in PowerPoint to give a more visual example of these concepts.
So this is our normal distribution. Here our y-axis is the frequency of scores and the x-axis represents actual scores. As I mentioned previously, we can identify the exact proportion of scores above, below, or between certain points in this distribution using the mean and standard deviation. More specifically, scores between one standard deviation above and below the mean encompasses 68.26% of all scores in the distribution. Between two standard deviations has 95.44% of the scores, and so on. Now let's talk about how to use the normal curve. What we want to do is convert our raw scores into what we call z-scores. What z-scores do is standardize all scales with a mean of 0 and a standard deviation of 1. So it essentially replaces what you see here as this x bar with 0 and these 1 standard deviations, 1, 2, 3 standard deviations with 1, with a z-score of 1. What this means is that we can compare the same scale or compare scores on different scales. For example, if you and a friend are very competitive and you want to make a bet of who is smarter, but unfortunately your friend took the SAT and you took the ACT, which has different scales that are not comparable, z-scores can standardize those scores to the same scale. The z-scale always has a mean of 0 and a standard deviation of 1. So let's take a look here at the z-score formula. We have the raw score as indicated by x sub I minus the mean divided by the standard deviation. And what this does is it standardizes all raw scores on the same scale. Let's compare that to the normal distribution. As you can see, a z-score of 1 directly corresponds to a standard deviation of 1. A z-score of 2 equals a standard deviation of 2, and so on. And so the mean is equals 0, standard deviation of 1. So let's plug in an example of YouTube star Jenna Marbles. And let's say she's interested in knowing how her video titled How to Care for Your Cermit compares to her other videos in terms of the number of likes it received. That specific video had 275,000 likes. Fortunately, YouTube gave her data for her other videos as well. She has a total of 200 videos, so that's our N here, with an average of 225,000 likes per video, which is represented by our X bar or our mean, and a standard deviation of 30,000 likes, and that's represented by our S here. We can use this information to plug in the data. We plug in 275,000 for the x sub I, 225,000 for the x bar, and the standard deviation of 30,000. And what you see here is our final z-score of 1.66. This means that the video How to Care for Your CERMIT is 1.66 standard deviations away from the mean or greater than the mean. Now let's take a look and compare that on the normal distribution. As you can see, the raw scores align with the mean and standard deviations for the other two scales. Except what we're doing here is we're taking this particular scale and getting the mean of 225,000 and then identifying the standard deviations there. So our mean for Jenna Marble's video, which is 225,000 likes with a standard deviation of 30 likes, corresponds with a z-score of 0 and a standard deviation of 1. This allows us to calculate where on the distribution her How to Care for Your CERMIT video falls in comparison with all other videos. We can even take this a step further and find the exact percentage of videos, of Jenna Marble's videos, with less likes than her How to Care for Your CERMIT video. This is what we call the percentile. One thing to note on this distribution, the middle point equals 50%, meaning all z-scores that are negative are less than the 50th percentile, and all z-scores that are positive are greater than the 50th percentile. This lets us easily find the percentile. This helps us because when you look up your percentile for a z-score of, let's say 1.67, something like we have now, and if you find a percentile score less than 50%, you know that something's wrong. So you can use your intuition here a little bit to help identify those percentile scores. Now, using the table here or a similar table called a z-table will help us find our percentile score for Jenna Marble's video. Make a note that these tables can sometimes be counterintuitive, and this one is no exception. You want to put a little bit of logic and reasoning behind these tables, and remember what I said about positive and negative z-scores. Because our z-score here is on the positive side, right, it's going to be greater than, at least at a minimum, greater than 50% of the population or of the other videos. So just keep that in your head. So first, we find our z-score. So using this chart here, we find our z-score, which is 1.67. And as you can see, both columns are less than 50% or less than 0.5. But again, because our z-score is positive, we know this can't be the case. So how do we find our actual z-score? So let's talk about each of these columns real quick. What the B column is telling us is the area or percentage of scores between our score and the mean, right? And so in this case, this is 45.25% of the scores are between our z-score and the mean. Remember, again, the mean is always the 50th percentile. So what we could do to find our percentile here is add 50% to this number. Another way to do it is that column C is telling us that the percentage of scores above our score is 4.75. So another way to do this is to subtract this number from 1, because we know 1 is the entire population of scores. And so that's what I typically do when I have a positive z-score like this, is I take 1 and minus that from the area beyond, or minus the area beyond from 1. And what that gives us is a percentile rank of 95.25%. Essentially, what this is saying is that we're taking 100% of the scores and subtracting the scores that are greater than ours. This gives us, again, our percentile of 95.25%, telling us that How to Care for Your CERMIT video has more likes than 95.25% of all of Jenna Marble's other videos.
By now you should know what the normal curve is, how to calculate z-scores, and how to determine percentiles. Thanks for watching Stats with Chaz. I'm Dr. Charlie Collins.